Hi guys, today we are going to be going through a pretty tricky tree diagram probability question. Um, Shout out to Natalie who asked for this video. Um, so this is for you, Natalie. Hopefully when I go through it, it's going to make way more sense. As you can see just by looking at it, it's there's a lot going on, and I think that part of the problem with this question is actually interpreting what it means. So it looks like it's the millionaire type quiz show. Who wants to be a millionaire? And we've got Peter, who has got a probability of 0.7 of getting an answer correct. And he can get it wrong at 0.1, or he might ask for help. So the first question, as you can see, is asking to show that the probability is 0.89. So show question means you've been given the answer, so you have to be really careful about showing as much working as possible to get that 1 mark, because they know that you already know the answer. So if they're going to get the first question correct, Peter will either answer it correctly. So that's going to happen 0.7 times, 0.7 probability times. Or, so when we say or in maths, we put plus. He could ask for help. And as a result of asking for help, he could get it right, which happens 95% of the time that he asks for help from the audience. Okay, so if you chuck that in a calculator, you get 0.89, which gives you that first mark. So, okay, things are not too bad at that point. They then give us some further information. On the second occasion that Peter decides to ask for help, he phones a friend. And the probability that this friend gives him the correct answer is 0.65. The first thing I would always notice with a question like this, we are looking at 6 marks. So you know that it's not going to be an easy question. So I felt like there was a little bit of ambiguity with it. Some of my students thought that it meant that the second occasion he always asks for help and that he doesn't have an attempt of answering it himself. That is not how it's been interpreted, okay? So what it actually means that if he does ask for help a second time, as in he's already asked for help from the audience, then he's going to ask for help from a friend as a possibility still of 0.2. So I'm just going to adjust the tree diagram for you so that you can see what is going to happen. So he's answered one question correctly as per this diagram, or he's answered a question. So whether it's correctly or wrongly, he's answered one question. After he's answered it correctly, he can still answer it correctly again. And the probability of that is still 0.7. He can still answer it wrong. And he can still ask for help. Now, this particular option of the branch, this top one, he hasn't actually asked for help in this situation yet. Okay, so it's still going to be the first time he asks for help. So in that particular situation, he's going to be asking for help from the audience. And when he asks for help from the audience, they're either going to get it right 95% of the time, or they're going to get it wrong 0.05. So that's the second question. Now, the other option that we're kind of looking at is this bottom option here. So he may ask for help on the first question and he might get it correct. And then we've got a whole lot of scenarios that could happen. So then when he goes for his second question, he can get it correct. He can get it wrong. Or he can ask for help. Now, this is the situation where he's asking for help for the second time. He's already asked the audience. He now is going to phone a friend. So that's a 0.2. And when he phones a friend, he's got a 0.65 chance of getting it right. So there is a lot going on. So in order for you to find the probability that the first two questions are both answered correctly, we have to go through every possible scenario. So if we follow the top path, super simple one that he could happen. He could just get it right. Gets it right again. And that gives us 0.49. Okay, so that's the scenario here, 0.7, 0.7. Correct, correct. The next scenario that could happen, he could get it correct, and then he could ask for help and get it correct. Okay, so if we follow that path, we're getting the first one correct, we're asking for help with 0.2, and then we're getting it correct, 0.95. The next one, he might ask for help with the first question, get it right, and then just get it right by working it out himself, so not asking for help for the second one. So that next one, running out of room here, there's so many things going on, is that he asks for help, the audience gets it correct, and then he simply answers it correct, the second question correct. So both of those end up with the same numbers. So we're looking at 133 for both of those. The final option is that he asks for help, the audience answers it correctly, and he asks for help again, and the friend answers correctly. So that's a final situation. So if we write that one down, he asks for help, the audience gets it correct, he asks for help again, and his friend gets it correct. And that one is very unlikely at 0.0247. So if you add all those up, you will get 0.781 and get your 6 marks. So not simple. And then if you've got this far, you still have a 3 marker to go. So that's a given question. So as soon as you see the word given, hopefully you're thinking it's a conditional probability, because it is. So this conditional probability, we've got probability that he answers the 2 questions. Oh, we get it around the right way, don't we? Whoops. Find the probability that Peter asked the audience. So it's a probability that he asked the audience, given he got 2 correct. So with that formula, remember the top is going to be both of those situations happening simultaneously. So he asked the audience and gets 2 questions correct. And the bottom is just all the possible ways of getting 2 questions correct. Now you'll notice that that bottom is the answer from above. So you could have got the part 2 wrong, and you will get full follow-through marks if you used your answer from here and put it down here. So the top is the only bit that we really need to work out for this question. So that's just the probability of the audience being asked and 2 questions. So if you have a look at all of those 4 things we looked at, the only one that doesn't involve the audience helping is that very top one. I'm going to unhighlight it in order to illustrate it. So it's this option here. Okay, so that's the only one which involves him not asking the audience, but still getting them correct. So we have to add all the other ones up that we used. So we're going to be using this one, and this one, and we're just not going to be including the 0.49. So it's going to be 0.133 plus 0.133 plus 0.0247. And that gives us 0.2907, which we would divide by 0.781, and we would get 0.372, which is our final answer. So that is our fun tree diagram question of the day. I hope that made sense, and I hope that helped you out, Natalie.